Hey, what's up? Great example of one of my favorite kinds of geometry questions. Let's dive right in. The big questions that all geometry questions on the exam are asking you is number one, do you know the formulas? And number two, did you draw a good diagram? And if you're not doing both of those things on every single geometry question, then you are your own worst enemy. This problem is going to be no exception. There are some really cool alternative approaches that we can make use of. But at the end of the day, you're going to see it's going to come back to those two things I was just talking about. Let me prove this to you. So we've got a parallelogram, we've got a midpoint, and if you haven't figured this out already, one of the most important truths of the quant section is that it is extremely rare, like 1 in 1,000 or more rare, that a quant question is going to give you information that you don't absolutely critically need to answer the question. And geometry questions are a very, very good example of that. So if they're telling me it's a parallelogram, I need to know that. If they're telling me E is the midpoint, I need to know that. That's going to be critical to the solution. And that might seem redundant or obvious, but it's actually really valuable to just remind yourself of that when you're approaching geometry questions in general. Area of triangular region. Okay, so I know this is a triangle, and they're asking me for a fraction comparing the area of this triangle to the area of what looks to be a trapezoid. They're just calling it quadrilateral region, so let's not make any assumptions here. Let's just execute on our game plan, and let's draw a good diagram here. Now, when I say good diagram, I do want to be clear, I don't mean perfect. It just has to be solid, good enough for you personally to not miss questions you know how to do. That's really the metric that we're going for here. If you're missing questions you know how to do, then your diagrams aren't good enough. If you're getting questions you know how to do right, your diagrams are good enough. If you're missing questions you don't know how to do, that's actually a really simple fix. Pretty much everyone knows how to know more stuff. That's stuff you've been doing your whole life up until this point, and that works on pretty much every exam, this one included. So if you're missing questions you don't know how to do, just learn more stuff. But if you're missing questions you do know how to do, that's a huge, huge issue. And you want to really look at your scratch work if that's happening to you, specifically your diagram on geometry questions. Okay, really important with a good diagram is making sure you get that critical given information I was just preaching about into your diagram itself, because one of the nasty truths of the quant section is what makes it to your scratch pad is what makes it to your head. And if you're not writing it down, it's probably not sticking the way that you need it to. Now, there are exceptions to that. Some of you are super geniuses and your short-term memory is like 10 times more effective than the average person. And for you, you're not struggling with this, so hey, that's awesome. Enjoy your given abilities from birth. For the rest of us who don't have that superpower, again, if you're missing questions you know how to do, you want to look to what am I writing down? What is making it to my scratch pad? And if you don't struggle with that, awesome. So parallelogram here, that means each of the pairs of sides is going to be parallel. And if you don't know what parallel is, then that comes back to this foundational principle. I'm not going to do a ground up build of geometric knowledge here on this question because I strongly doubt if you're watching this video that you need that. However, if I do bring in some information that you're not familiar with and I don't wind up explaining it, then probably a quick web search is going to net you the result that you need there. Okay, so BC is going to be parallel to AD. Parallel means they never intersect, and AB is going to be parallel to DC. All right, that's nice to know. I am sure I'm going to need that, but that's not like ringing any bells or giving me any penetrating insight into this question. So let me get the rest of the stuff down here. E is the midpoint of AD. So I'm going to notate that AE and ED are equal. The area of triangular region, ABE. Okay, so I know this is a triangle. That's great. Okay, so now I just want to visually represent my question. So I want the area of triangle ABE, and I want that as a fraction of the area of BCDE. All right, cool. Looks like I'm set up for success here. I've captured everything that they've given me. It's on my scratch pad, and I'm ready to start doing math. Now, at this point, there's several different options that we can take. Some of them are situational. Some of them are going to be just personal to you, whatever type of approach you personally prefer. I'm going to take you through a couple of what I think are the most important to discuss, but I'm not necessarily saying these are the only approaches to this question. So if you have one that personally works better for you, that's cool. I'm never going to argue with your results. If you're getting great results, keep doing what you're doing. All right, so I want to tackle the official guide's explanation first, because the official guide, if you haven't figured this out already, is pretty bad in terms of its explanations. That's why you're probably watching this video right now. But let's give the official guide some credit. Let's call it a 50% hit rate on great explanations. Okay, so maybe 50% of the explanations are solid, and then the other 50% are just horrific in my opinion. Sorry, GMAC, just being real. But I think that the solution in the official guide for this particular question is actually valuable to think through, and it's worth discussing. So the official guide, more times than not, is going to take what I'd call like a pure algebra or a pure math approach to these questions. And there's nothing wrong with that. Again, if that resonates with you personally, use it. Take the test the way that works best for you. So what the official guide does is it assigns some variables to some of the unknowns, and you might have already realized as you were working through this problem originally or just watching what I'm doing that they haven't given me any side lengths or really any concrete values at all. Like, I don't know if this is 5 or 500 or 5 million. Like, maybe from A to B is 5 million. Maybe it's like this massive, massive parallelogram. Or maybe it's tiny. Maybe it's 0.000005. I don't know. So when we have unknowns, and we're going to take a pure math approach, that's why we create variables, and that's the time to create variables. So what we want to do is focus on our end result. What are we trying to wind up with? We need the area of this triangle. So I'm going to just do what I personally like to call the divide and conquer strategy and just solve one piece of the problem at a time. So I'm just going to focus on how do I figure out what the area of ABE is. First thing I'm going to need to know is the length of the base. And the second thing I'm going to need to know is drop an altitude that forms a 90-degree angle with the base, which is popularly called the height of a triangle. And if you haven't memorized that area of a triangle is 1/2 times the base times the height, then you've got your work cut out for you here over the next couple days. But the good news about geometry formulas is if you don't know them all, a few days and a few flashcards later, if you stay consistent, you'll be probably good to go. All right, so I need a base and a height. If we're taking the official guides route, then we're going to just assign some variables. So I'll call this B for the base, and I'll call this H for the height. And the official guide assigns somewhat different variables, but it's basically the same premise. This is the way that I personally like to do it. I think the official guide just uses AD as the length here, but I'm really not a fan of using AD for a variable because I think that's inherently confusing to a lot of people's basic understanding of algebra. Like, your algebra teacher in school probably never used 2 variables to represent one unknown. Like, that would be very unusual. So I think it can lead to people being kind of error prone with their scratch work, circling back to like make sure you get questions you know how to do right. So I'm just going to go with the single variable thing, but if you like the AD thing, again, all good. Okay, so because I just made this variable B and H, there isn't a whole lot for me to do here in terms of filling in the numerator of this fraction I'm trying to solve for. Like, that is literally just going to be 1/2 times B times H on the numerator of our fraction. So now what I'm going to do is set off attempting to find the area of this quadrilateral here, and I'm going to try to use B and H within that calculation, and let's see if I can make that happen. So we've got a couple options here. We can just do the area of the parallelogram and then subtract away the area of the triangle. That's one option. Or we can go straight for the area of what I'll call this shape, which is popularly called a trapezoid. A trapezoid has 2 parallel bases that are not necessarily equal, and then 2 non-parallel sides, like you can see with BCDE here. Again, plenty of ways to slice and dice this one. I'd prefer not to have to subtract the triangle from the overall parallelogram area, but it's always good to have options. So I would think about that, but then I would just go with calculating the area of this thing directly rather than indirectly. So the formula for area of a trapezoid is the average of the bases, which will be the parallel sides. The parallel sides are going to be the bases, times the height. Okay, so that's to be average of the bases times the height. The good news here is the variable I declared over here for the height of the triangle is also the height of this particular trapezoid. And that's because these two lines, BC and AD, are parallel. So boom, I'm already using this given information. That's a good sign that I'm doing the problem correctly. H is just going to be H. That's always good. And then I already know that because AE and ED are equal, that's the definition of a midpoint, then this is going to be a length of B. So I know one of the bases of my trapezoid is just going to be the length of B. So I'm going to put that right here. I'm going to average that with the other base, which we'll get to in a second, and then I am going to multiply that by the height. All right, so now all I need to do is discover what is the length of this thing. And this is where it's really going to come back to this thing that I let off the lesson with that I'm going to preach about a lot on geometry questions if you follow my stuff, is do you know the formulas? Do you understand what a parallelogram is? Have you taken the time to really memorize it, really understand it? And if you haven't, again, you're making this thing harder than it needs to be. So because the definition of two parallel lines is that they never ever ever intersect, that means the distance between two parallel lines at any given point, the straight line distance between these two parallel lines, is always going to be equal. It's going to be equal forever and ever and ever and ever. Like if you imagine these two parallel lines are the side of a ladder, and these rungs of the ladder are going straight across, the rungs of the ladder are going to be perfectly equal to each other all the time because the lines never ever 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 intersect. They go straight in exactly parallel directions. And if that doesn't make sense to you, then reach out to me and I'll find another way to explain that to you. But I'm just going to assume that you understand that concept visually. And from that, we can conclude that the distance from A to D is going to be equal to the distance from B to C. And so this total distance up here is going to be 2 times B. That's going to be 2 times B. So I'm going to fill that in right there. And now I'm just going to average these bases, multiply by the height, and start canceling some variables on the top and bottom, and hopefully that's going to get me my answer. Let me just try to do this one little piece at a time so that things don't get too crazy. Let me deal with the denominator first. So this is going to be 3b over 2. 3b over 2 times h, and then this is going to be 1/2 times b times h on the top. All right. I always want to cancel things in fractions if I can, just to simplify the situation. So I'm just going to start by canceling the h on the top and the bottom. H divided by h is just 1. And I'm going to separate the 1/2 and the b, or keep that separate on the top. And then I'm going to separate this 3/2 here and then this b here. That's on the bottom. Instead of 3b over 2, I'm going to treat that as 3/2 times b. And hopefully visually for all of you who struggle with fraction math, that makes it a little easier to see that b is going to cancel out. So b divided by b is just 1, and I wind up with 1/2 divided by 3/2. Now, I think the temptation for a lot of us here is to do that in your head, but I really don't recommend that. When you're dealing with double-decker fractions, or really fractions of any type, try to keep it as visual as possible. You'll wind up missing fewer questions you know how to do. You'll go to better graduate schools. You'll have more impact. You'll make more cash. You'll make a bigger contribution to the important people around you. You'll have more joy, fulfillment, all the good stuff. Okay, and I'm telling you the price of admission for that is just write out some fractions when you're doing the math. So here, if I'm dividing by a fraction, that's the same as multiplying by the reciprocal. I'm going to visually cancel the 2 on the top and the bottom. I'm demoing exactly how I would draw this if this were test day, okay? So if you think this is just for the lesson, these brackets I probably wouldn't be drawing if I'm being totally real with you, which I always am. I probably wouldn't be boxing and arrowing all this stuff because that's more for the lesson, but everything else besides the boxes and the arrows, I would be literally physically drawing out on test day so that I don't miss a question I know how to do. I don't want to give away any points to this exam. It's already hard enough. So here I'm going to get 1/3, and bam, one step closer to grad school. All right, so that's kind of a close replica to what the official guide recommends, and let's talk about the virtues and vices of that approach. So the good thing about that approach is it works. It's really not that bad. All the variables end up canceling out. The math is not too horrific, and I pretty much get the job done. I don't have a huge problem believing that I could execute this in 2 or 3 minutes. So that's good. That's what I like about it. What do I dislike about it? There's a boatload of variables floating around in here in the double-decker fraction. That could make me very error-prone. That could make me miss the question even if I did know how to strategize on it. Even if I did know all the stuff and I did draw a good diagram, I might still miss it just because running the numbers can get intense with the time pressure, etc. So I want to show you an alternative that I personally prefer, although this approach is definitely worth knowing and definitely worth rehearsing, because sometimes you're going to be able to use the approach that I'm about to show you, and other times you might not be able to use the approach I'm about to show you, and you might be cornered into doing some pure algebra. So even if you don't love this, I would recommend getting at least moderately comfortable with it, to the point that you feel, okay, I could theoretically, believably execute this in 3 minutes or less. It doesn't have to be your go-to strategy. It doesn't have to be amazing, but it's got to be believable, okay? Now that we got that done, let's pivot to an approach that I personally prefer, and I'll talk you through why. So let's back our way out to where we were when we first set everything up, and we were talking about some of the forks in the road we could take strategically, and we went down the sort of pure math, pure algebra approach. So what's another avenue we could take if we wanted to? Well, one avenue that's really, really great for geometry questions where you're not given any concrete lengths of anything is, instead of plugging in a variable, you can just plug in a fake number. We're making everything up with the variables anyway, so we're really free to pick whatever numbers that we want. And as long as we obey all the constraints in the problem, all the math is going to work out, and I'll show you this in just a second. So while the mechanics of the solution are going to be somewhat similar, The specifics of the solution path, I think, are just preferable for me personally because it's just a little bit less friction. So instead of creating a variable here, I'm just going to plug in a number. And I can choose any number I want, so I'm just going to go for 10, something like that. And I'm always trying to pick a number that seems like it could make my math relatively straightforward. Let's see how 10 plays out. If I don't like 10 later, I can just change it up. And similar mechanics, I'm just going to divide and conquer. I'm going to start with solving one part of the problem first, and that'll be the area of the triangle. So base of 10, and then I'm just going to pop in the height here. And I think I'll just pick an arbitrary number, like let's go a height of 3, something like that. Because we've already walked through the logic, you're going to see how that part of the problem is quite similar. But what I'd like you to consider, if you don't do so well with variables and like a pure math approach like we just looked at, that it might be easier to walk through that logic if you have some concrete numbers in front of you. And you'll probably know what type of thinker, what type of problem solver you are. So, of course, this is also going to be 10, like we demonstrated. E is the midpoint, and then from B to C, that's going to be 20. And that should give us pretty much everything we need to compute what we want to have happen over here. So let me take this out. We know this is the area of the triangle on top now, so that's going to be 1/2 the base, which is 10, times the height. And then on the bottom, we're going to do the trapezoid, which is going to be the average of the bases times the height. So that's going to be 10 plus 20 over 2. Let me clean up my scratch work, times the height, times 3. Now you're probably looking at this thinking about how you can cancel stuff, which is great, but if you imagine we're starting the problem fresh from this point, think about how much simpler we could theoretically make the computation now. Let me show you exactly what I'm talking about. So 1/2 of 10 is 5. 5 times 3 is 15. And then 10 plus 20 is 30. Divided by 2 is 15. 15 times 3 is 45. Or we could just think about it as 15 times 3 on the bottom. Either way works. And you can see that that 15 is going to cancel out, and no surprises here, we get the same answer that we got previously. So if you want to, just rewind the video and see how much more scratch work was involved in the previous solution path, and hopefully that is evidence enough of why I personally prefer this kind of approach in a question where I can use it. Again, you won't always be able to use it, so the previous one is definitely worth understanding. But if you want something that's takeawayable from a problem like this, then I think probably the most important takeaway for the widest number of people is going to be to look out for those geometry questions where you're not given any concrete values, and be willing to experiment with plugging in some values for yourself. Now, if this strategy doesn't resonate with you for any reason, that's completely fine. Double down on what works for you, like I've said so many times already. If you have questions about this, feel free to comment below and or reach out anytime. And if you'd like to learn how to reach your dream GMAT score in half the normal time and with half the normal effort, just click the link anywhere around this video, and we'll be happy to show you how. Talk soon.